So in the yesterday class, I already started discussing about the Seaborn library. Why we are using this library, I already discussed about that. Okay. So we already know what is the correlation. We already know that one. So I'm just importing this one. Otherwise, I can't run the today's topics. So we know for when we are started working on the Seaborn, we have to import this library, import Seaborn as SNS. Okay. So here this one is our data frame. We are loading our datas using this SNS library. So for that, we have to use this one sns.load underscore dataset. Here we are loading our dataset. This one is our data frame. Okay, which dataset we are loading? This one is that one. This one is our data frame. We have the columns total bill, tip, sex, smoker, day, time, and size. These are is our features. So you already know what is the correlation. Correlation basically meaning the relationship between the features. Here we are selecting these features, total bill, tip, and the size for calculating the correlation or the relationship between these features. So for calculating the correlation between these features, we have to write this code. df.select details using this built-in function, we are selecting the features. Using those features, we are calculating the correlation between this. Okay. Here we are printing the correlation matrix of these three features. Okay. Okay. This one, from this, we started our today's topic. That one is the heat map. Heat map is a representation of the correlation matrix. Heat maps is a representation. Okay. Here we are using these lines for creating our these heat maps. Heat maps basically represent the correlation between these three features. This is the pictorial representation of the correlation matrix. These dark colors represent that the mostly correlated values, and after that the light color from this, it's represent the correlation value is lesser than this. So in this way it's working. This dark color represent the highest correlated relationship between these two features, and this and light and lighter than this is represent that the means represent if the value is decreasing, the color will be the decreasing in these heat maps. This is the color representation of our heat maps. Okay. Sorry, this is the pictorial representation of our correlation matrix. From this color, we can understand the how these two features are correlated with each other. Okay. So here we already discussed about the univariate analysis, bivariate analysis. Univariate analysis basically means the maximum two independent features. Maximum two independent features. That one is called if we have in our dataset, if we have maximum two independent features, then that relationship is called the univariate analysis. Okay. So for representation, means for representation the univariate analysis, we need this joint plot. For representation the univariate analysis means for relationship between two independent features and one dependent features, the relationship between this or one obviously it's also possible with the one dependent, that one univariate analysis. So for representation of the univariate analysis, we need this joint plot. So using the help of this joint plot, we are representation here the univariate analysis. X is our one features and Y is our another features. X is tip, tip is one features, and Y is the YOLO bill. Y is the total bill. This one is our second feature. So we are here comparing between these two features. This is called the univariate analysis. Here within the data, we are initialize our data frame. DF is our data frame. So here within the data we are initializing our data frame. Here kind equals to hex, because when we are representing this joint plot, we are not using any other means circle or any other means structure for representing these data points. Here we are using the hexagonal for representing the data points. These points are like the hexagonal. So for that reason here kind equals to hex. So when you have one independent features or two independent features, then you have to do the analysis is called the univariate analysis. For representation of the univariate analysis, we have to use this joint plot function. Here we are using this joint plot function. Here x is one features and y is another features. Okay, here x is one features, y is another features. Here we are basically comparing between these two features. Okay, and here within the data we are representing our data frame, and here we are also initialize kind equals to hex, because here our data points are for that. Okay, so when you are using the when you are doing the univariate analysis, you need this joint plot. Okay, another here, when you are this one is the hexagonal structure. Okay, in this command we are using we are also using the joint plot, because we are also comparison between these two features, tip and the total bill. So here kind equals to rig here basically means the regression function. Rig is basically represent the regression function. From the means we all know the equation of the line is y equals to mx plus c. Here m is basically means the slope, and c is basically means the intercept. We all know that one, that the means equation of the line, we all know that. Here regression basically we are finding the best fit line between these two data points, the best fit lines within these two features, the best fit line. Okay, so here that line represent the best fit lines within these features. Okay, so when we are means studying in the machine learning field, then we means these concepts are clear, which one is the best fit line and what is the regression, what is the classification. So for that concept we have to discuss in our the next machine learning class. Okay, so now you just have to know here this line is the best fit line within these two features. So when we are using this regression, it basically finding the best fit line within these two features. So here we have a two independent features. So for that here we are using the joint plot, because this one is the univariate analysis. So after running this, our representation of the these two features. Okay, so if you have any question about from the joint plot, you can ask me in your chat. No, it's not basically two numerical features. Means in any features you can also draw the joint plot, but main when we are doing the univariate analysis, means comparing between two features, comparing between two independent features, then we have to use the joint plot. It can be numerical value, can be another values. Univariate analysis is the one type of analysis. It's not the all kind of types, nothing like this. Univariate is basically meanings when we are we already discussed about the independent features and the dependent features. If you have maximum two independent features and one dependent, univariate analysis. And if we have one independent features and one dependent features, then also it's also called the univariate analysis. Maximum in the univariate analysis you have two independent features. All there is no other types present in the univariate variate features. Analysis are different types, univariate, bivariate. These are the different types of analysis are present there. Okay, in the pair plot, you have in the pair plot basically represent the bivariate analysis. Okay, pair plot basically represent the bivariate analysis. If you have two independent features and one dependent features, then you have to use the pair plot. Okay, then you have to use the pair plot. Pair plot basically also means represent the matrix. So pair plot is also represent the scatter plot, and this is basically the permutation and the combination of the all features. If your features have this represent this graph is represent the permutation and the combination of the all features. Mean the using the pair plot, different types of graphs are present here. Okay, means how many types of relationship between these two features are possible. This all this representation are the present here. So using the pair plot, this is not any types of means graph is present here. 2-3 types of graphs are means relationships are present here. Okay, so if you have here, we are using three features. Okay, so if you have two independent features and one dependent features, and in the bivariate analysis basically means you have maximum two independent features and one dependent features. But univariate analysis basically in the univariate analysis also the one independent features and one dependent features is also present. But in the pair plot is only represent the two independent features and one dependent features. Here we are using two independent features and one dependent features. Okay, the size and the total bill is relationship with the tip. Okay, if the size of the persons in the restaurant are increased in the group, then total bill will be increased, and if the total bill will be increased, then the tip will be increased. Okay, so in this way, if these relationships are present here, this is the permutation and the combination of these three relationship between these three features. Okay, so this is basically represent the pair plot. This is basically represent the scatter plot. You already know about the scatter plot in the matplotlib. This is the different types of relationship between these three features which are possible. Okay, which type here represent with the total will represent with the size, tip relationship with the total bill, tip relationship with the tip itself, tip relationship with the size. These types of relationships are permutation and the combination of the all the relationship between these features. Permutation and the combination of the all the relationship between these features. Okay, so here also this one is the one representation of your features. This one is the another. Here the difference between this command is here we are using another features here. That one is the sex features. Okay, sex basically the categorical features. It only has two values, female and the male. If it only has two values, female and the male, so we are representing here these three features with hue. We are with another variable hue we are using. That one is the sex. Means your total bill, this blue color represent the male features paid the total bill, and this portion is represent the female features represent means paying the total bills, but male number is high than the female numbers in our data set. Male presents a high number than the females. Okay, male number is high than the female. So for that reason, graphs like this high peak represent the male sex present in our data set, and this low graph represent the female in our data set. Okay, so this one is the male and this one is the female. So we are also means here we are comparing between these three features also, but another another features is also present here. That one is the sex features. We are using that in the categorical features. Hue value must be a value that will be a categorical. Okay, here sex is a categorical features because it containing only two values, female and male. No other values are there, female and male. Here you can also use the smoker also. Smoker is also another features present in our database, that is also a categorical features. Here in our database, another another features is here. No features is only containing two types of values, yes and no. Okay, and sex is a features that is also containing that one is also a categorical features, that values are only two types, female and male. So in the hue when we are using this variable, when you are using this parameter in this parameter in the pair plot, this parameter will be must be a features that containing these two means that containing the categorical features. You can also try by yourself after this class with instead of using the hex, you can also use the smoker here. After that, you can visualize what will be the graphs, what will be the outputs, and what will be the visualization of your graphs. Okay. So here we are comparing between these two features with respect to the another feature. That one is the sex features is present here. Okay. Next plot we are using here the dis plot. Dis plot basically presenting the histogram. Okay, dis plot basically presenting the histogram. Okay, so here we are only using one feature, that one is the tip. Here we are only using a histogram with these features. Okay, means how consistency present in these features. Okay, these are basically represent the density in these features, density within in these features. If the t value is between the 0 to 2, the density is like this 0 0.1, 0 0.2, 0 0.3. These are basically the percentage. Okay, so here this one this plot is basically represent the histograms, means when the t value between 0 to 2, the how much density is present here. So this one is the 1% density is present. These are the percentage. Okay, so these are the percentage here, and this one is the histogram. And here another parameter which we are using in the next command, that one is the KDE. KDE is true here. When KDE equals to true, we are not right here. If we are means initialize our KDE equals to false, then we have to write this one here. So here KDE is true. KDE is basically means the kernel density estimation. KDE, the full form of the KDE is kernel density estimation. This basically represent the density of each values present in the means features. Okay, means if the value of the features t value present between 0 to 2, the density like this. If the t value present in 2 to 4, the density like this. Okay, so this is basically the histogram of this one features, t features. So from this you have an idea about, so using this plot you have an idea about how the features is. This feature is high when mainly tip are given, maximum tips are present within this range. 2 to 4. Okay, maximum tips are present within this range, 2 to 4. So for that reason, sorry, 2 to 3. So for that reason here, the plot is high here. Okay. And maximum density is present, and after that, the maximum tip are present between 3 to, mainly this one is a 3.5 to 4. Okay, 3.5 to 4. So using this, you can have an idea about the where the tip value is high, and means how much maximum tips are given to the student. So in this plot, you have an idea about your that features, a particular features. The idea is about this. Okay. In the next command, when we are using the KDE equals to false. Here kernel density is false and beans equals to 10. So after this, your graph is like this. So after this, your graph is like this. One is another representation of the TIF features. This one is another representation of the TIF features. Okay. So so using uh, this plot, you can draw the histogram of each features. You can draw the histogram of each features. Okay. So if you have any question about the pair plot and the disk plot, you can ask me in the chat. Displot not particularly use any kind of analysis. Using the displot, you can draw the uh, histogram of each features. Okay. So next, we're discussing about some. So which plots we are drawing here, all are representation of the continuous features. These plots means joint plot, disk plot, pair plot. These are basically present the relationship between the continuous features. Okay, these are the continuous features. Okay, so that total bill, tip, size, these are the continuous features. Okay, and this sex, smoker, day, the sex and smoker, this one is the categorical features. This one is the categorical features. Okay, because it's containing only two values. Like this outputs of these features must be a two, between these two, female and the male, and smoker output is also between these two, yes or no. These are basically called the categorical features. But the total bill, tip, and the size, these features are not the categorical features. These are the continuous features, because these values are outputs are not two types. These outputs are many types, from 0 to infinite. Many types outputs will be present here. So these features are called the continuous features. Okay, and day is also one type of categorical features, and time is also one type of categorical features, because the 5 types of days output within the 5 days, and the time is also a categorical features, because output is within a range, means breakfast, dinner, or lunch, within this range. So these are called the categorical features. And other this total bill, tip, and the size, these are the continuous features. So up to this, the displot, join plot, and the pair plot, it represent the relationship between the continuous features. So now we are discussing cat features, the categorical features like male and the female, like this. So here we are representing one categorical relationship between one means here we are the representation between the means with the categorical features. Okay, so how the total bill related to the sex, this categorical features. Okay, so relationship between these two features means this one is the male paid the total bill, and this represent the female paid the total bill. Okay, so for that, we are using here the bar plot. The bar plot basically we have to use on the categorical features, because we have one categorical features here. That one is the sex. So when we are basically comparing the one continuous features value with one categorical features value, then for that we have to use this bar plot. Mean how many number we are counting here. We are counting here. Basically, we are counting here how many bills, total bills are paid by the male person, and how many total bills are paid by the female person. Here we are counting this one. Okay, so for that we have to use this bar plot. So for that we have to use this bar plot. Here the y-axis is represent the sex features, and the x-axis represent the total bill features. Okay, here y-axis represent the sex features, and the x-axis represent the total bill features. Okay, so this represent the this number of females are paid the total bill. This is the number of male paid the total bill. Okay, so for that we have to use the bar plot, because here we are comparing with one categorical features. So for that reason we have to use this. So another we are representing. So this one is the vertical bar plot, and this one is the horizontal bar plot. Okay. So in the previous class, one student is asked me about the, please ma'am, represent the bar plot in if possible we can represent the bar plot in the horizontal way or the vertical way. Yes, that one is possible. When we are changing the means the x value and the y value, your bar plot representation is also changed here. Okay, so this is a vertical bar plot, and this one is the horizontal bar plot. Why this output is the horizontal? Because here the x features present in the x-axis, and the y features present in the x features the sex feature present in the x-axis, and the total bill features are present in the y-axis. So after executing this one, our bar plot is in the vertical representation of our bar plot. Okay, so this one is our data set. We all know we are just here just representing here anotherly, and here another one is the box plot. Okay, here another one is the box plot. Here we are representing the relationship between the total bill with the two categorical features. That one is the day, and another one is the smoker. Okay, these two categorical features we are comparing between these two features. Day means which day the maximum total bill will be paid. We are comparison between these two features, but another parameter we are using here, that one is the smoker. That one is the smoker. This blue color represent here the smoker, and the orange color represent here the non-smoker. Okay, so here we are representing a graph. Just one our categorical features we are representing here, and X is our continuous features we are representing. We are basically comparing between those two features. Okay, means which day the maximum total bill will be paid. This graph is represent that, and another constant is present here. Mean the Sunday, this amount of non-smoker are present here. This amount of non-smoker are present in the Sunday, and this amount of non-smoker Sunday paid this amount of bill. Okay, this amount of total bill, and this blue present in the smoker, this amount of smoker paid the total bill in the Sunday. So maximum smoker are present from this graph. We can observe that the maximum smoker are present in the Sunday. The Saturday is less smoker are present from the Sunday. Okay, and the Friday and the Thursday, obviously the values are lesser than the Sunday and the Saturday. And here from this, and also the total bill are maximum paid in also the Sunday. So from this graph, we are comparing between these categorical features with these continuous features, and also another parameter we are using here. That one is the smoker. So this one is another, means this graph is representing between this relationship between these three features. Okay, the smoker features, and another one is the day, which day the maximum smoker are present, and which amount of bill are paid by the smoker and the non-smoker. Okay, this graph is like this. Okay. So here another box plot we are drawing here, another box plot. So here we are basically comparing between these graphs is the vertical types of this, and here change the y value. Here y value present the total bill, and the x value present the day features, and data is data frame. We are using our data frame. So df the name of our data frame, the data set we are using here. And for different types of color, we want to, if you want to use different types of color, you just have to write palette equals to rainbow. Here the rainbow colors we are using here. So for that reason, this another parameter we are setting here, the palette equals to rainbow. So in this way, you can draw another box plot. Okay, so these are like the vertical box plot. These are the horizontal box plot we are representing here. So if you have any question about this box plot, you can ask me. Box plot and this bar plot. If you have any question about these two plot, you can ask me. This is my first class, is not this is my first class, so not much clear. So you have to go through the YouTube links which are present in our WhatsApp group. So when you study your previous class, you can easily understand this class. Okay, the last thing we are discussing about the violin plot. This is the combination of the bar box plot and the kernel density distribution. We already discussed about the KDE, kernel density distribution. So this violin plot basically the combination of the box plot and the kernel density distribution. Okay, this one is also the represent the relationship between these two features, total bill and the day. Here total bill is present in the x-axis and the day present in the y-axis. Data is our data frame and palette is our rainbow. This violin plot basically the distribution. It's not only represent the means these are the values, particularly values. This represent the distribution within these values. Okay, this represent the distribution within these two features. So for that reason, graph is like this. Okay, the others plots are represent the means values, not the distribution. So for that reason, output is like this, and this one is the distribution between these two features, means KDE, kernel density distribution, is also represent within these two features. So for that reason, graph is like this. So these are the so using the Seaborn, you can draw the relationship between your features. Okay, the relationship between your features. So this one is very interesting. So up to this, our Python library, which we want to discuss in this this complete here, that up to Seaborn, our Python tutorial is finished here. So if any other important things if I miss, then I will cover in our later class. But in the next class, the machine learning, I will start the machine learning tutorial. The machine learning tutorial is basically the theoretical things, because in the machine learning tutorial, I am just covering the machine learning tutorial for that will help you for means clearing your interviews in the data science. So machine learning tutorial will be related to that one. And up to this, the Python tutorial we finished, because this up to this libraries, within this help of this libraries, you can start your data science career with this with the help of this library. These are some basic things I have discussed here. In your means for your job or anything else, you have to learn the Python more than this, because you have to try it by yourself, you have to practice it. And these are the some basic libraries we have discussed in our sessions. This helpful for your data science career. Okay, so from the next class I start the machine learning tutorial. That one is a theoretical tutorial basically, and we have to cover that one for clearing our data science interviews. Okay. Okay, no, we start the data science, after that the statistics. So please practice yourself with this Yearborn library. You can try with any means data set from the means any online available data set. You can try the features, the relation, you can try the using the Yearborn library. You have to try the means box plot, bar plot, this plot, joint plot, pair plot. You have to try it by the yourself with the help of that features. Means you have to draw this relationship between your dataset features. So if you try with different datasets, so from that you have the clear idea about the why we have to use the Seaborn library. And these types of thing means you have to try by yourself. Okay, no, I am not giving any collab link, because if you means that YouTube link is given to you, and you have to write the code from the YouTube to your collab. It will helpful for you practicing your means it will help you to understand the code properly. Otherwise you just copy and paste from the Google collab, so it's not very much means good for you. So for that reason, I am not sharing that one. You have to means write the code from the YouTube to your collab. Please everyone practice yourself. Otherwise, you can't means learn the Python, because this one is a programming language. It's not possible cover all these things in the means classes, because programming language is basically you have to learn by yourself. This one is the main move on anything. So thank you everyone for joining, and are you enjoying this session, this Yaban session? Please reply. Oh, this attendance is taken by the that anyone is, I think, present in the Stu Value Technologies, they will take the attendance. Thank you everyone for joining, and please join the next session. That one is about the machine learning field. So thank you everyone for joining. Have a good day. Bye.